Now that we have been through the various plasters and techniques used for closing up a defect, we'll move now to the use of local flaps in closing defects in the head and neck. There are various ways to describe a flap and several proposed classifications. Conveniently, they can all be combined into a system with sub-items starting with a C. The first C is the circulation, like it can be a direct vessel going to the flap, like in axial flaps, or indirectly through musculocutaneous branches, like in random flaps, followed by the composition, which refers to whether you are using a full thickness skinned flap or partial thickness, including fascia, muscle, or even bone into your flap. The third C refers to conditioning of the flap, either by delaying to improve its vascularity or expanding the tissue using tissue expansion. The construction of the flap itself refers to the flow of the vascular flow, whether through a single pedicle or bipedicle, conformation of the flap into a tube or combining flaps. Contiguity refers to whether you are the distance between the flap itself and the defect, whether this is direct, local, regional, or distant, or even a free flap. The contour is one important aspect of classification because it refers to the method used to transfer the flap into the defect, either through advancement of the flap in a linear movement or rotation around the pivot, like in rotation flaps and so on. This last C, referring to the contour of the flap, forms the basis of a common system of classification of the flaps into advancement and pivotal flaps. Advancement flaps are those flaps that are moved in the one linear direction without any rotation or lateral movements, like in single pedicle advancement flaps or bipedicle or a V to Y flaps. But when the flaps are rotated around a pivotal point, they can either be rotation, simple rotation flaps, when the flap is directly rotated into the defect with no intervening tissues, or if the flaps are rotated into the defect over a partial intervening tissues, they are called transpositioning, like in Z flaps, for example, or if they are crossing over an intact bridge of intact tissues, they are called interpolated flaps. We'll come to this in a second. We'll go through the general classification of the flaps first before moving to one flap at a time. The first group is the advancement flaps group, including a single unipedicle advancement flap or a bipedicle, two advancement flaps meeting in the midline, or the island flap, a V to Y type of flaps. We also have examples from O to L advancement flap and the east-west advancement flap. And then we'll move to the rotation flaps, either single rotation like the dorsal nasal flap or the scalp flap or the cheek rotation flap, or a double rotation like the one usually used in the scalp, the O to Z type of plasty. But when the flaps have to cross an intervening tissues in order to lie in its new position, they are called transpositioning flaps. Like in this example, you would have to you have to raise up the whole of the flap and cross over a partial intervening tissue in order to reconstruct this flap. Examples are the bilobed flaps and the cheek as well. And then to interpolated flaps, in which the flap has to cross over an intact bridge of skin to reach its destination. Example is this paramedian forehead flap. The origin is in the forehead, centered over the supratrochlear artery. It has to cross over intact skin to reach its destination to cover up a defect in the nose, and the flap will be sutured over the defect and left over until new vascularization takes place, and then at a second stage it will be released from its origin and this area will be repaired. The single-pedicle advancement flap here used to cover a rectangular type of a defect, but it can be circular or triangular if needed. You will consider first which side you would want to base the flap on. You can base it superiorly, inferiorly, or medially, but obviously laterally here is the best option. Then you will have to consider the lines of the flap to be parallel to relaxed skin tension lines, and the length of the flap to be 2 to 1, for example, the length to the breadth. And then you would draw up the Burrow's triangles at the base of the flap. This should be about half the breadth of the defect, and once the Burrow's triangles are removed, the flap can be slided in a linear movement to fill up the defect and sutured first at the leading edge, the apices of the leading edge, and then the area of the Burrow's triangles where you have the maximum tension, followed by suturing of the remaining lateral parts of the flap. Defects can have various forms and various shapes. In this example, it's a circular defect lying below the lower eyelid and beside the nose. For this, the design of the flap will be modified in order to have incisions parallel to the relaxed skin tension lines. So you have the upper incision parallel to the lower eyelid and the lower incision parallel to the nasolabial fold. They are no longer parallel to each other, and you don't have to be parallel to each other. You have a wide base to supply the length of the flap after mobilization, and you can also consider where to have your Burrow's triangle in order to remove any excess or redundant tissue. And in this example, you can have the Burrow's triangle and the lower incision rather than the upper incision. This is to illustrate the planning and the technique of the Plasty of the bilateral advancement flaps. If you have a rectangular or a square defect in the midline, in the forehead or the lips, the lesion is excised and you have all the parallel lines parallel to the relaxed skin tension lines on both sides, and you've marked the Burrow's triangles toward the base of the flap on the two sides, and these are excised to ease the mobilization of the flaps from lateral to medial to meet up in the defect. And once they reach the midline, they can meet the other flap and the midline, keeping the symmetry, and it's not too difficult to close up the Burrow's triangles after this, and this is the final outcome resembling an H. Another advancement flap, the VY or the island flap. If you have a defect with a diameter of an X, you can mark a triangular flap with a leading edge of an X and a length of 1.5 to 2 X's. The lesion is now removed, and the completely separated piece of skin here that is detached from all its surroundings is advanced into the defect, pedicled only on its subcutaneous attachment. This is where the blood supply is coming from. Once in place, it will be sutured. The leading edge will be sutured in place, and then you will mark a suture at the apex of the flap. This is where most of the tension is. Flap dimensions. The leading edge of the triangular flap should be equal to the diameter of the defect. That's an X. The length of the flap should be between 1.5 and 2 X's, and the angle at the apex should be about 30 degrees to prevent a dog ear formation. And if there isn't enough tissue on one side of the defect, or if there isn't enough tissue laxity, you can have the flaps from both sides meeting up, particularly in the midline, where symmetry is required. The VY Plasty, as opposed to the VY flap, is a technique of suturing a V-shaped incisions or wounds into a Y configuration. You need that sometimes if you have a large defect where you would expect too much tension in the center, or would you expect some dog ear deformity at the edges. You need here a release incision, and if you choose to have a V-shaped release incision of this shape, not reaching up to the defect itself, it stops here, then you can advance that piece of skin with no much tension to affect primary closure. You'll be left with the V-shaped release incision that is going to be sutured like a Y. We now plan a release incision for this wound, and if we choose to have it like a V-shaped, you extend the incision only halfway to the edge of the defect itself. You don't go all the way up, you end up here. Once you have the design in place, you can now incise the release incision and undermine widely. Now that should make it much easier for the wound edges to meet up with no much tension and no dog ears deformity. Once this is done and you've closed the primary wound, you are left with the V-shaped incision that's now closed like a Y. This is the V to Y Plasty. We move now to rotation flaps. It starts by drawing a triangle around a circular or a square lesion. The base of the triangle should be as close as possible to the lesion itself, and the width of the base should be about approximately the diameter of the lesion. Then you draw an isosceles triangle with the angle at the apex equal about 30, and the length of the triangle should be about 2 to 2.5 the width of the base. And once the triangle is the base of the triangle is then extended like a curvilinear line about 5 to 6 times the diameter of the lesion, 5 to 6 times axis. And lesion with the triangle are excised. Curvilinear line is incised now, and it's ready to be mobilized, but you see a dog ear forming at the base, a Burrow's triangle, equilateral triangle with half x in dimension would be created, and now you can mobilize the flap to fill up the defect. One alternative to excising Burrow's triangles, if you don't want to discard with viable tissue, is to have a back cut at the other end of the curvilinear line. So rather than excising the Burrow's triangle, you make a back cut here, making sure that you are not compromising the blood supply of the flap that goes from the base. Once you have the back cut in place, the flap can be mobilized easier into the defect itself. The defect that's going to be formed by mobilizing the flap away from the back cut would usually be closed in a V to Y type of reconstruction. In the case of bilateral rotation flaps, recruited from the either sides of the defect but going in opposite directions, you will end up with an O to Z type of reconstruction. So you'll draw the two flaps on the opposite directions on both sides, and because you are using two flaps rather than one, you can have the curvilinear line extending about 3 times to 2.5 times the diameter of the defect. Once the flaps are created and elevated, they can now be mobilized to meet in the midline of the defect. and once this is sutured you will see a Z rather than an O. So that's the final closure. Moving now to transposition flaps and taking the rhomboid transposition flaps first. These are a family, a group of flaps with the original description of Limberg and some other variants. A circular or a square lesion is changed in configuration to a rhombic defect. This rhombic defect has the characters of being equilateral parallelogram. The angle at the apex is 60 and the angle at the other side is 120. So the short diameter is equal to the sides of the rhombic as well. And when extended to the outside, equal size again, and then a line is drawn parallel to one of the sides of the parallelogram, and these two lines would also be equal to the sides of the parallelogram. This lesion will be removed and the flap will fill up the defect. And you can have a double Limberg and a triple Limberg, where you have the modification with Dufourmental flaps, the Quabas modification, the double Quaba modification, and then the Webster modification or the diamond flap modification. Starting with the original Limberg flap, this is the rhombic configuration, equilateral parallelogram. Then we extend the short diagonal to the outside, equal length, and drop a line parallel to one of the sides of the parallelogram. All these lines are now equal. The lesion itself is excised. The flap is mobilized and transposed into the defect. This is where you have maximum tension between the angle of the flap and the parallelogram, and the leading edge is now secured inside, and you have the sides also now sutured. And you can have a double Limberg if the lesion is too big or if it is oblong in shape. You now draw a parallelogram with a length to breadth ratio of 2 to 1, can be divided into two rhombics, and then you extend the short diameter to the outside as usual and have a line parallel to one of the sides of the parallelogram. Do the same on the other side, and now you have two flaps, two Limberg flaps on the sides. The lesion itself is excised, and then the two flaps are transposed to meet up in the middle of the defect, and the secondary defects are closed primarily. Needed, you can have a triple Limberg to fill up a very large defect. Here we don't draw parallelograms outside the lesion, we draw them inside. We draw three small parallelograms inside the lesion by having three diagonals intersecting at 60 degrees. Then we extend the short diagonal of each to the outside, equal length, and drop a line parallel to the parallelogram, equal length again, and then you would have now three flaps going in the same direction around the circular defect, which is now excised, and the flaps would be released and undermined and transposed to fill up the defect and meet there, and you'll end up having this configuration as like a Mercedes-Benz type of a mark. With a Dufourmental flap, you can work with rhomboids with angles different from the classic 60 degrees and 120 degrees. You can work with 30 degrees and 150 degrees rhomboids. You first extend the short diagonal to the outside, draw a line, and then extend one of the sides of the rhomboid and draw another line and bisect the angle here, and that's the first limb, and drop from there a line parallel to the long diagonal of the rhomboid, and that would be the flap, the Dufourmental flap. The lesion is then excised, and the flap can be transposed to fill up the primary defect, and it would be easier now to close the secondary defect because the angle is narrower and you have less of a problem with a dog ear deformity at the angle of the scar. The diamond flap modification was suggested to reduce the amount of healthy tissues excised around a circular defect to get the rhomboid shape. This piece of healthy tissue can be preserved, and now the shape of the defect would not be a rhomboid, it would look more like a diamond shape type of a defect. Equally, the flap designed to fill up this defect can be modified because it no longer has to fill up the whole of the rhomboid by reducing the amount of the flap in this area. So it is a tissue sparing technique. You would draw the rhomboid shape as usual, but this time rather than excising these pieces of skin at the top, you would try to preserve this. Now extend the short diagonal and one of the sides to get the Dufourmental flap design. And now the lesion is excised, sparing some part of the tissues here at the top. This is a diamond shaped lesion and a diamond shaped defect, and you can use this to reduce the amount of the tissues that need to be transferred to fill up the defect as well, and the secondary defect can be closed easier, like in a straight line, and you have filled up the primary defect with the diamond shape flap. The Webster Flap introduced two modifications to the original description of the rhomboid flaps. The first is to have an M plasty at one of the acute angles of the rhomboid, and this would entail preserving a piece of healthy tissue that would have otherwise been lost. The second modification is to have the angle at the apex of the Dufourmental flap 30 degrees, and this very acute angle would help in transposing the flap into the primary defect, and also helps in closing up the secondary defect with less tension and less likelihood of having a dog ear deformity. So you start by drawing up the rhomboid shape, and you will then mark the flap by extending the short diagonal and one of the sides of the rhomboid, bisecting the angle. Now, rather than having a line parallel to the long diameter, you draw 30 degrees and get a line equal in length to the rhomboids. So this angle is 30. Now you mark the M plasty at the apex of the rhomboid on one of the short of the acute angles, and now you can preserve that small piece of healthy tissue. Once the defect and the flaps are marked, you excise the lesion, sparing that piece of healthy tissue here to help in the reconstruction. Lesion is removed, and the flap with the acute angle is raised and transposed into the primary defect, and now you have this small piece of skin helping in closing up the primary defect, and it's also much easier to close up the secondary defect as well because of the acute angle here. Another variant is the square peg into the round hole variant described by Quaba. Here we don't draw any parallelograms outside the circular defect. we just extend one of the diameters 2/3 of the way up, and from at 60 degrees angle and equal length limb, 2/3 of an X again, and here you are, you've got a small parallelogram that is going to be transposed into the circular defect, hence the name. This is where you have most of the tension, the suture between the base of the flap and the defect. And once you have the leading edge of the parallelogram in place, you can secure by suturing the lateral limbs as well. And this is the area that would need attention, the maximum tension, and the secondary side can now be closed as well. The bilobed flaps were probably first introduced more than 100 years ago. Since then, the technique and the design has been modified in several ways, and the original design is rarely used nowadays. But it introduced the general principle of utilizing a double transposition flaps. If there is a defect that requires a local flap, and the site of the local flap cannot be closed primarily because there is no enough tissue or no enough tissue elasticity around to close the site, you can utilize a second flap to close up the site of the first flap, and then try and close the site of the second flap primarily. And in this way, you can utilize tissues by recruiting it from areas relatively far from the original defect. Zitelli proposed to reduce the arc of rotation from 180 degrees between the primary defect and the secondary lobe to something between 90 and 110 degrees. So the arc of rotation between the defect and the first lobe is reduced to 45 degrees rather than 90, and the same applies to the angle of rotation between the first and the second lobes of the flap. And this reduced the tension on the tip of the flap and reduced the shortening effect and the potential retraction of important landmarks. He also suggested to have the second lobe as an elliptical or a triangular in shape to ease the primary closure of the defect. In Zitelli's technique, you start by marking a line from the center of the circular defect, extending to the outside with a length equal to the radius of the circular defect, and then draw a 90 degrees line and bisect it so that you have a 40 degrees angles between these two lines. And then you draw two arcs, the first from the center of the defect, the other from the circumference of the defect, and these two arcs would have a radius of twice the radius of the defect or 3 times the radius of the defect for the outer arc. And then you draw the primary flap around the first line and the secondary flap around the second line, and these two flaps should be almost equal in size to the primary defect. And then you elongate the secondary flap so as to close it primarily, and you also excise a small piece of skin at the base of the primary defect. Now the two flaps can be transposed easier into the primary defect and the secondary defect, and by removing this small piece of skin you can close up the secondary defect in a straight line. A further modification to the Zitelli's design was then proposed. You still extend a line from the center of the defect to the outside, and this line would be measuring twice the radius of the defect. It would be equal to almost the diameter of the defect. And then you draw either a 90 degrees or a 110 degrees, bisect these so you get a 45 degrees each or a 50 degrees if required,
and then draw two arcs from the center of the defect. The first arc would intercept with the 45 degrees in the center of the primary flap, and the second will be in the center of the secondary flap. Now, the further modification was to elongate the primary flap about 10 to 20% more than the size of the original defect to avoid creating any shortening or retraction due to the pivotal rotation. And the same applies to the secondary defect, which can be a little bit, the width can be a little bit reduced, almost to about 60 or 70% of the width of the first flap, but it would be stretched in length for more than 30% or so. This increase in length between the two lobes of the flap would cancel out any shortening effects.
We've been through the classic and the common types of flaps used in reconstruction and in the head and neck region, and now we move to the less common flaps used for specific applications, together with the distant flaps, particularly the deltopectoral skin flap and the pectoralis major muscle flap.